In this video lesson, we're going to be looking at polygons. And more specifically, we're going to be looking at the interior angle measures and the exterior angle measures of polygons. Okay. Now, a polygon can have a different number of sides, but let me go back here. Notice that in this polygon, we have drawn what's called some diagonals from a common vertices, so from B to D and B to E, and we've created 3 triangles. The number of triangles is always 2 less than the number of sides. That's what you see right here with this n minus 2. And since we know that all triangles have a sum of interior angles that equals 180, then what we're going to end up doing is multiplying this n minus 2 times 180, and we'll see that as we go along. And we'll take a look at some. So here's some examples of some polygons, and based on their side lengths, what they're called. So obviously you know a triangle, and then here we have a quadrilateral. This is a rectangle, could be a square or a rhombus or a trapezoid or a diamond, those kind of things. And then we have 5-sided, it's a pentagon. We have the 6 hexagon, 7-sided heptagon, 8-sided octagon, 9-sided nonagon, and a 10-sided decagon. Okay, and we'll probably stop there for this lesson. All right, let's look at a little examples, some terminology. This here is an equilateral polygon because all of the sides are shown to be the same length. We call that equilateral. Now, if a polygon has all the interior angles are the exact same measure, we call that equiangular, an equiangular polygon. And then a regular polygon is a convex. I'll get into that in a minute. And a regular polygon is where all of the side lengths are shown to be the same and the angle measures are shown to be the same. All right, and then finally, a little bit more terminology here at the last. A convex polygon, and we have concave polygons. The convex is where all of the angles are pointed out. The concave is where one of your angles is inside or pointed inside. Okay, so you can see like this angle would be more than 180 degrees. So that's the definition of a concave, whereas the convex, all of the interior angles are less than 180. So when you have an angle that's greater than 180, that's because it's pushed inside. That's called concave. All right, let's look at some questions you might see on your assignment. So this first one is where you're just identifying the types of polygon. It says to fill in the blanks in the drop-down menu. So the first thing we're going to do is count the sides. This is a 7-sided polygon. It is convex. None of the angles are pushed inside. And since it's 7, it's called a heptagon. All right, and this one here, you will also count the sides. This one has 9 sides, okay? Now, all of the side lengths are shown to be the same, so it is equilateral, but not equiangular because the angles are not shown to be the same, and it is called a nonagon. So you'll have some questions similar to that. All right, now, here's where we're going to begin to use our theorem here, where basically what we understand is that the sum of the interior angles is the number of side lengths minus 2 times 180. And let me explain why. Now, this first one just says to use diagonals from a common vertex to show how many triangles could be formed on a polygon below. So here's what we do. We have a common vertex, so I'll start here. So I'll draw that. I'll connect those, and I'll connect these two. That wasn't a good one. And then I'll connect these two, and so on. All right, and then you can see how many triangles. We have 1, 2, 3, 4, 5, 6, 7. So the answer to this one is that there would be 7 triangles. Well, and what that should also be equal to is n minus 2, because if we counted the number of sides, 1, 2, 3, 4, 5, 6, 7, 8, 9. There is 9 sides, and 9 minus 2 equals 7. So the number of triangles is always 2 less than the sides, the number of sides. All right, and this question, this says, what is the sum of the interior angles? Well, what we have just learned is the sum is equal to the number of sides, n minus 2, times 180. Well, if we count the sides, 1, 2, 3, 4, 5, 6, 7, we would just do 7 minus 2 times 180, which is 5 times 180, which equals 900 degrees. All right, now, this question says, what is the sum of the interior angles of a nonagon? Okay, well, we know what a nonagon is. It has 9 sides. So we would do 9 minus 2, which is 7, and 7 times 180, which gives us 1,260. So that would be the answer for this one. Now this one says, how many sides does a regular polygon have if each interior angle measures 162? Okay, this is a little bit more involved, but what we know is that we take the number of sides, which we don't know in this one, but the number of sides minus 2 times 180 is going to give us the sum. But then if we divide the sum by the number of interior angles, then that equals each individual angle. So we've set up this equation where 162, the individual angle, is equal to the sum of the interior angles, which this is how we get the sum, divided by the number of interior angles. Okay, so to solve this equation, notice that this side is being divided by x, so we multiply both sides by x. Again, the reason we do that is because these x will cancel. All right, so then what we have is 162 times x, 162x equals, and then when you multiply 180 times x minus 2, x times 180 is 180x. Negative 2 times 180 is minus 360. Then you have an equation where you need to get your like terms together. So we're going to subtract 180x from the right side so that this cancels. And then over here, 162x minus 180x is negative 18x. And that now equals negative 360. Then you just divide by negative 18, and x equals 20. Now you can check your work by plugging it in over here. If you plug in the 20 everywhere, we see this x, 20 minus 2 times 180, and see, does it equal 162 when you divide by 20? So 20 minus 2, 18 times 180, that's going to be 3,240, and when we divide by 20, we do get 162. So yeah, 162 equals 162. All right, now in this problem, this just says, what is the sum of 4 of the interior angles of a regular pentagon? Now, a regular pentagon is going to have 5 interior angles, okay, but it's just asking for the sum of 4. Well, the first thing we need to do is figure out the sum of the regular pentagon. Well, that's 5 sides, so 5 minus 2 times 180, that's 3 times 180, which is 540. Then to get the angle, each individual angle, we would take the 540 and divide it by 5. This is a regular pentagon, so they're all the same. 540 divided by 5 is 108. So each interior angle is 108 degrees. And it asks for the sum of 4 of the interior angles. We just multiply 108 times 4, and we get 432. All right, now, the last thing we're going to talk about is the exterior angle theorem. That just says that the sum of the measures of exterior angles of a convex polygon one angle at each vertex is 360. So the sum of any convex polygon is 360 degrees. Doesn't matter how many sides. Now this question says the measure of the exterior angles of a pentagon are represented as 2x, 4x, 6x, 8x, and 10x. Solve for x. Well, we know that the exterior angles of any polygon equals 360. So we just write our equation. 2x plus 4x plus 6x plus 8x plus 10x equals 360. Combine your x's, we get 30x equals 360. Then we divide by 30 and x equals 12. All right. And then this last question here says the exterior angle of a regular polygon measures 15 degrees. How many sides does a polygon have? Well, again, if the exterior angles of a regular polygon always equals 360, or the sum always equals 360, then we can just do 360 divided by the 15 degrees for each angle, and this equals 24. So this would have 24 sides.